All right, it's time for Belovsky Science once again here on October the 22nd, 2020. My fourth day of Corona vacation, you might say, being locked up in the house, teaching class from miles and miles away, ready to be back in the classroom, tired of doing this remote teaching, would much rather be with y'all because it is a whole lot easier. But anyway, got a couple of things that we need to run through with y'all. I'm going to pop the warm up here. Of course, your warm ups will need to be turned in tomorrow, so make sure you get all your warm ups in. Here's your warm up. You'll know how to do that. There's no need for me to go into detail with that. All right, a couple of things that I need to show you here. Let me show you a couple of things here. Let me pop over here to the classwork page. This right here is Monday, Chapter 2, Section 1. That is due tomorrow at 3:30. Some of you have not turned it in yet, and if it hits 3:30 tomorrow and you haven't turned it in, you're getting 50 points knocked off of it. I'm really setting in on these deadlines now. You have to have them turned in by a certain amount of time, and unless it's got an excuse with it, unless there's a doctor's excuse or a really good excuse from home, an excuse of like I had practice that I had don't care, or I tried to submit this work on my iPad and I couldn't get nope, sorry, it's not my responsibility. That's what your Chromebook is for. So make sure that you're getting your work turned in on time. All right. Your warm up, I just got through telling you, warm ups will be completed tomorrow, turned in. This chapter 2 section or lesson 2 thing that we've been working on, I may delay it a little bit because I'm wanting to try to, I'm horrible with technology. I'm trying to figure out if I can do a certain activity with y'all tomorrow. So if you're watching this on Thursday, bring some earbuds with you to class on a Friday because I'm going to try to do something that's going to involve sound with it. And if you've got your earbuds with you, it'll make it a whole lot easier on the people sitting around you and the substitute. So I may delay this from not being due on Friday. And if I do, I'll put a note in the stream and I will change this due time right here. So y'all please make sure that you're watching the videos when you're absent. And I'm going to tell folks this in class once again, because I had somebody to say to me, "Hey coach, I need numbers 1 through 6 today because I wasn't in class." Well, did you watch the videos yesterday? No, I did not. Okay, well, I'm not giving you the definitions because that's what the videos are for. The videos are for people that are absent to be able to go sit down and watch and see what went on in class. All right, so before you say, "Hey, watch the videos first," and that's what every one of these down through here is: absent on the 19th, absent on the 20th, absent on the 21st. If you're absent on the 22nd, that's what this is right here that I'm in the middle of making right now. So please make sure that you, when you're absent or not in class, that you sit down and watch the video from the day before. All right, let's run through some of this work real quick. Getting the book to pull up. Oh, that's the review sheet. And make sure you go to the bottom of your review sheet. Let me pull it down here where you should be. All right. And yesterday in class, we did numbers 1 through 6. Well, today you're going to start off with number 7. All right. So let me ask you a question real quick. Do you know what 2 major categories cells fall into? And it's not plant and animal. If it was plant and animal, what would you do about fungus? Because fungus is not plant or an animal. What would you do about protists, which are not plant or animal? All right, so there is 2 groups, and these words you've probably never heard of. One of them is called prokaryotic cells, and this right down here is eukaryotic cells. These are the two major groups of cells. So what's the difference between the two? It sounds technical. Oh, prokaryotic and eukaryotic cells. It's actually very, very simple. Here, let me show you a quick picture real quick of prokaryotic cell. This is the Wikipedia page, and this right here shows you a prokaryotic cell. Look in the middle of it and see if you can find the nucleus. There is no nucleus. What you'll just see right here laying in the middle is the genetic material, which is usually in the nucleus, but in this situation, it's just this big old wad laying in the middle of the cell. Prokaryotic cells do not have a nucleus, okay? So eukaryotic cells, which I am showing you here, this right here is an animal cell, and you'll notice there's a nucleus right here. It is eukaryotic, okay? Prokaryotic does not have a nucleus. Eukaryotic does have a nucleus. So what do we write down for this? Okay, well, it's very simple. If you will go to your textbook right here, all right, let me pick out a pen here, and I like that color blue. Let's work with it. All right, prokaryotic cells, the genetic material in a prokaryotic cell is not surrounded by a membrane, okay? It is not surrounded by a membrane. In other words, it doesn't have a nucleus around it. It's just got this. It's just got this. It's just got this genetic material all strolled out in the middle of it. Okay, so there's no nucleus there. Okay, so of course, what is eukaryotic? Well, you've already figured that one out. Oh, I made a mark. Come on, help me out a little bit here now. There we go. Eukaryotic. Okay, what is eukaryotic? All right, give me my marker back. All right, eukaryotic, the definition is right here. Plants, animals, fungi, and protists, those are examples of eukaryotic cells. So what is a eukaryotic cell? A eukaryotic cell has genetic material that is surrounded by a membrane. In other words, it's surrounded by a nucleus. Okay. So, and examples are these are plants, animals, fungi, and protist cells. Bacteria are prokaryotic. There's no nucleus. Okay. So hit pause and type eukaryotic cell. All right. So you just got through typing in eukaryotic cell. Prokaryotic cells are extremely small. You can fit about 10 of these things into one of these. Eukaryotic cells are bigger. Prokaryotic cells are much smaller. In other words, bacteria is extremely small. All right. And a prokaryotic cell is called unicellular. And what unicellular means is uni means one, cellular means cell. So unicellular means one cell. And this is a one-celled organism. Yeah, that's hard to believe. It's only one cell, and it's its own individual being. But that is what it is. It is life. It is its own organism. Here we are trillions of cells, and we're able to think and eat and do all these other things. This guy right here, what you're looking at, is also a living organism. Now, it doesn't have the thought processes, and it doesn't do the complicated things like that we can do, but it is an organism because it can take in energy. It needs water to survive. It produces wastes. It reproduces, and it does the same things that us other living things do as well. So this right here is a great example of a unicellular organism. It is a prokaryote. Eukaryotes are what you'll find in most of us more complex beings. they are able to carry out numerous functions at one time. For example, a animal cell is able to, in the mitochondria, burn energy, while the Golgi apparatus is storing things and preparing to move things around in the nucleus or in the cell to another location. The endoplasmic reticulum prepares to move things around inside the cell, while the smooth endoplasmic reticulum prepares to get rid of unnecessary waste products and toxins from the cell. The plant cell has chloroplast that it is making food for the cell, while the nucleus is making decisions on when to grow and when to reproduce. There's multiple things that go on inside the eukaryotic cells. All right. Number 10 on your Chromebook is nucleus. All right. So what is the definition for nucleus? Oh, I nearly skipped organelles. Sorry. Number 9, organelles. All right. The definition is structures called organelles have specialized functions. And that's what I just got through telling y'all. Things like the Golgi apparatus stores things and prepares to move them around. The chloroplast makes food for the plant cell. The nucleus is the one that's in charge of handling things, taking care of everyday business inside the cell. Those are all organelles, and they all have their own job. Hit pause and write in organelles. All right, so you've now typed in organelles. Take a guess. What is the largest organelle inside of a plant? If you guessed nucleus, you are correct. In the average cell, usually the nucleus is going to be the largest organelle. Now, there are some cells that are different. Like there's some plant cells that a vacuole is something that stores things. The vacuole will be bigger than the nucleus. Or sometimes in the animals or in animal cells, there's a cell that's called a fat cell, and sometimes the fat cell will have a very large vacuole in it. But the vast majority of time, the nucleus will be the largest. It will be the largest organelle in the cell. All right, so we need to write down a definition for nucleus. And here it is right here. All right, let's pick out a little bit different color. All right, the nucleus is the part of the eukaryotic cell, that directs cell activities and contains genetic information stored in the DNA. Sorry, I kind of got crazy a little bit right there. So the nucleus is the part of the cell that directs the cell activities and contains genetic information stored in the DNA. Hit pause. Okay, you've got nucleus typed in now. Okay, so the nucleus is what's in charge usually of the cell. It's where the genetic material is stored, and it's the genetic material that absolutely tells the rest of the cell, okay, this is what needs to be done, and this is when it needs to be done. Okay. And the rest of the cell doesn't do like, oh, I'll do it later, and I'm not going to do it now, and I refuse to do this work, because if that happens, the nucleus has a certain little organelle that he's in charge of called a lysosome. And the lysosome, if the organelles don't do their jobs correctly, it will go over and destroy them. And so the lysosome, it basically is in charge of getting rid of any organelles that don't do their job. So must be very nice to have that roaming around making sure everything does its job properly. All right, now the next word is chromosomes. And the definition for chromosome is located right here. It's right next to nucleus. DNA is organized into structures called chromosomes. All right, that's number 11. Hit pause and we'll talk about it. Okay, you've hit pause, and now you got chromosomes written in. Chromosomes is basically the genetic material inside the nucleus. As the DNA, when the DNA is in the nucleus, it twists. Remember how we said that the DNA looks like a twisted up ladder? Okay, well, it twists itself even more when it's inside the nucleus, and it twists itself and it folds itself up, and so that it can be stored easily. Okay. It's kind of like when you go on vacation and you get your suitcase out and you put your clothes in it. Well, you just don't throw clothes. Well, most people don't. They don't just throw clothes in it. Basically, what you do is if you put your clothes in there nice and neat and folded, then you can get more stuff in there and it's organized and you know where everything is. Well, that's what your chromosomes is. DNA is nice and neat and it folds itself up so that it will fit nice and neat into the nucleus. And that's what a chromosome is, basically. All creatures don't have the same number of chromosomes in the nucleus. We have 46 chromosomes in our nucleus. Kangaroos has 12. And don't sit there and think to yourself, the bigger and smarter, the more chromosomes, because there are bigger creatures out there that are twice our size that has fewer chromosomes than us, and there's little bitty creatures out there that have way more chromosomes than us. So the number of chromosomes does not determine size or intelligence. No, nowhere close to it. Just think about it. Us humans, we have 46 chromosomes. Well, that doesn't determine necessarily the intelligence of a human being. You have some human beings that are extremely intelligent, and you have other human beings that are not extremely intelligent. So don't get wrapped around the thing that intelligence is determined. It helps determine chromosomes, because that is not true. Now, on the inside of the nucleus, if you'll look right here, now here's the nucleus right here. If you'll look in the center, you'll see there's this dark purple area right in there. Here, I'll draw a circle around it. Right there. That thing is called a nucleolus. Here, let's take a look at some other things. Here's the nucleolus right here in the animal cell. And in the plant cell, it is located right here. What is the nucleolus? Okay, the nucleolus is, I guess I need to hit pointer and bring it up. Here we go. The nucleolus. I need to get on the right page here. This is number 12, by the way. The nucleolus makes ribosomes, organelles that are involved in the production of proteins. All right. All right, the nucleolus makes ribosomes, which are organelles that are involved in the production of proteins. Type that in now. Hit pause. Okay, the nucleolus, which is this spot in the center, is what makes these things called ribosomes. And if I click on one of these pictures here, you will see these little black areas that are right through here. Those are ribosomes. And here's some that is right here. These are ribosomes. If you'll look through here with the little blue things that you see are ribosomes. Okay, so what do? Ribosomes make proteins. And ribosomes are made by in eukaryotic cells, they are made by the nucleolus here in the center. And so why is that important? Well, ribosomes make proteins, and proteins are what makes tissues for you to grow with and to repair when you skin your knee. So that is why that is very important, because the ribosomes is what helps you to make new tissues for growth and repair, basically. So the nucleolus is in the center, and it will be a dark area in the center of the cell. Number 13 on your Chromebook, you need to type in the word nuclear envelope. Okay. Nuclear envelope. And if you'll look right down here in the last paragraph, you will see envelope written right here in green. Well, the definition for nuclear envelope is this. The nuclear envelope contains many pores. Certain molecules, such as ribosomes and RNA, move into and out of the nucleus through these pores. Okay, that's a lot, I know. The nuclear envelope contains many pores. Certain molecules, such as ribosomes and RNA, move into and out of the nucleus through the pores. Hit pause. We'll talk about it when you come back. Okay, what is the nuclear envelope? Okay, let's punch up a picture of it here. All right, if you will look, hard to see. Let me go to the, all right. If you will look at the nuclear envelope right here, the nuclear envelope protects the nucleus on the inside. It's just like when you when you mail a letter, all right, you put the letter inside the envelope. The envelope protects the inside, the stuff that's on the inside. Well, that's kind of what the envelope does here. And if you'll notice, you got to look real carefully. There's little openings all over the nuclear envelope. That's to allow ribosomes and RNA to be able to come in and out as necessary. Remember that the nucleolus is what makes the ribosomes. Well, once they're made, the ribosomes have got to escape out here into the cell. So they come through these openings that you see right here in the nuclear envelope. And the RNA also, remember, RNA makes its way in and out of those holes as well. Ribosomes can be found in two places in the cell. You can find ribosomes floating around here in the cytoplasm, and you can also find ribosomes in the endoplasmic reticulum. And if you look right here on this plant cell, you will see here where it says rough endoplasmic reticulum. Well, this right here is the rough endoplasmic reticulum. And this right here is what is called smooth endoplasmic reticulum. Lord have mercy, what a huge word, endoplasmic reticulum. That's why we're going to start saying ER right now. So, ER stands for endoplasmic reticulum, not emergency room, and as far as this class is concerned. So, ER, what is it? Specifically, what is number 14 that you need to type on your paper? What is rough ER? Rough ER. All right, let's go to the textbook here. Whoops, sorry. If you look at this picture right here, you'll see rough ER. These lines are the endoplasmic reticulum, and the little dots all over it is ribosomes. And that's what makes it look rough. It looks like that it would be rough to touch. All right, well, that is rough endoplasmic reticulum. So where does it get its name from? All right, well, if we look, let me get me a marker here. Okay, rough ER is the site of protein production. Rough ER is the site of protein production. All right, what does that mean? Okay, hit pause, type it, and I'll explain it in a minute. Okay, so you just got through typing in that rough ER is where proteins are made. Well, this is ER, and since the ER has all of these ribosomes all over it, it is constantly making these proteins. So it's just a place in the cell where proteins are created. Very, very simple. Okay. Now, the last word of the day is number 15, smooth ER. All right. What is smooth ER? Okay. It's in the very last line right here. Let me get my marker back here. All right. Smooth ER is important because it helps remove harmful substances from a cell. All right. Smooth ER is constantly removing waste products that the cell creates to get rid of it, to try to keep the cell healthy, which in turn keeps you healthy as well. Um, the smooth ER does not have any ribosomes on it, so it has this smooth appearance to it, and that's why it's called smooth. Well, that's it for the day. Not exactly sure what's going to be going on tomorrow. Those of you that are absent, if you know you're going to be absent tomorrow, come back and look for a video tomorrow. There may be one, there may not. I'm not exactly sure how tomorrow is going to go because, like I said, I want to do this one little activity, and I'm not really exactly sure I can do it here. If I was at school, it would be no problem. So I'm just trying to figure out how I'm going to do it from here. So, anyway, that's it for today. I hope y'all have a wonderful day, and we will talk at you later. Bye.